Before I begin this, I'll just apologize for all the background noise of the fans. I got a little fan filter set up on a box fan with a MERV 13 inline duct filter, just to make sure no dust settles on the laser, or as minimal as possible. I'll do a final dusting and cleaning of all the optics before I use it. But here's the setup that I'm currently using to inject the beam. I have a 650 nanometer diode on a little arm here, which is adjustable. Injecting into the cavity, I have this coming off of a kinematic mount, again with a reflecting broadband mirror. And this will inject the laser beam into the end of the ring cavity. So just to kind of go over things, you have the main oscillator here with the neodymium yttrium lithium fluoride rod, which you can kind of see illuminated down here. And this is the main oscillator and pump chamber. It goes through the shutter, and I have a couple of razor blades just kind of stuffed in to keep it open right now. Through an aperture into the dub prism, into the first leg of the Fabry-Perot Etalon. There's the passive Q switch. There's the second half of the Etalon. Out of this, you're going to get a couple of reflecting mirrors, which basically create the ring of the cavity, so it'll come up over the pump housing, back this way, and into this double mirror arrangement. So it'll come back down. Any frequencies that need to be reflected can get feedback into the oscillator, and it does a ring right here. So it's just one big ring going through this cavity section here. And then out of the ring cavity, it would eventually come back over here, bounce down off this mirror, come back to this reflector here, back down to the second mirror over there, through the telescoping lenses 1 and 2, or sorry, 1 and 2. Off this, it would come up through the polarizer into the amplifier, through the amplifier into what's called an SPS phase conjugating mirror. It's a scattered beryllium mirror. So basically it creates an acoustic standing wave, or an acoustic wave, which causes a perfect reflection or reversal of the phase information off the scattering surface. Comes back through the polarizer, off that mirror, through a small aperture there, into a wave plate. I didn't mention there's a wave plate before the SPS. A secondary wave plate into the frequency doubling crystal, and then from there it comes off a couple of mirrors back here, bounces, comes out. Part of the final output green laser goes into this energy monitor, and then finally out the aperture right there. So this is my current alignment setup, and you can see that I have the diode again injecting into the ring, going through the housing, coming back up over, aligning, and doing its thing. So this is my current injection setup, and we're just doing some basic alignment to check the cavity. After I check this, I'll basically reverse this and have the beam coming out of this path and tracing it to the input and reflection off the SPS, and then from there we'll test the final output in and out through the frequency doubling. So there's 3 stages to this alignment procedure that I'm taking, and so this is where I'm at in the process. Still working on getting this power supply back up and running, but for now the whole goal is to just make sure that the output in pilot mode is what it's called. It only uses this main oscillator. It does not use the amplifier. So my goal is just to make sure that everything is aligned, and we'll do pilot mode testing to make sure that this is firing correctly and we're able to get a green output of this laser. So if you have any questions, leave them down in the comment section below. Make sure you hit the like and subscribe for more.